Gauss's law in dielectrics. In the last class we have studied that when a dielectric is placed in a uniform electric field, due to polarization, bound charges are produced within the dielectric and is given by, the bound charges are given by, that is, the volume charge density is given by del dot P and the surface charge density, it is given by P dot N. That is, the charge produced within the dielectric is given by del dot P and the charge produced on the surface of the dielectric is given by, that is, sigma B is equal to P dot N, surface charge density and the volume charge density. So in a material, all other charges which are present and are not produced due to polarization are called free charges. That is, when a dielectric is placed between the plate of a parallel plate capacitor, this is a dielectric material which is introduced between the plate of a capacitor, and we are applying an electric field in such a way that this dielectric, it forms a charge separation. And these charges are called bound charges. That is, the charge formed over the surface of this dielectric, it is called bound charges. And these charges are called free charges. That is, in the conducting plates or the metal plates, there are free charges. Hence, we can consider the total charge density. That is, the total charge density. Total charge density, rho, can be represented as the charge density due to the bound charges plus the free charges. And these are the free charges and this is the bound charges. That is, the total charge density, rho, can be represented as rho B plus rho F. That is, the charge density due to bound charges and the charge density due to free charges. And here in the dielectric, the charges are induced due to polarization, and these lines representing the polarization, it is called the lines of polarization. And the lines of polarization which start from negative and it ends at a positive region, and these lines are called lines of polarization. And here the total charge density, rho, is equal to rho B plus rho F. And we know that the Gauss's law in electrostatics, that is, the Gauss's law in electrostatics is del dot E is equal to rho by epsilon 0. That is, rho is the charge density. According to the Gauss's law in electrostatics, whenever there is a charge and there is an electric field associated with it, here this charge density, rho, can be expressed in terms of the free charge density and bound charge density. That is, del dot E is equal to rho B plus rho F divided by epsilon 0. Or we are rearranging this equation. That is, epsilon 0 del dot E is equal to rho B plus rho F. But we have this volume charge, that is bound charge density. The volume charge density due to the bound charges, it can be represented as minus del dot P plus the free charge density. And we are rearranging this equation, that is, epsilon 0 del dot E plus del dot P is equal to rho F. Or we can represent it as del of epsilon 0 E plus P is equal to rho F. Epsilon 0 E plus P is equal to rho F. Or this term can be represented as, that is, epsilon 0 E plus P can be written as D, where D is called the electric displacement. where d is called the electric displacement and it can be represented as d is equal to epsilon 0 E plus P. Therefore, this equation becomes del dot d is equal to rho f. That is, the electric field is the electric field. The electric field can be represented in terms of the bound charges and also due to the free charges. But the displacement current, this can be electric displacement, can be represented only in the terms of free charges. And this equation, that is called the Gauss's law in electrostatics. Sorry, in dielectrics. This is the Gauss's law in dielectrics. And we are considering this equation in the integral form. That is, in integral form, this equation is d dot d is equal to q, where q, if enclosed, means the total free charge enclosed in the volume. The total free charge enclosed in the volume. Therefore, the Gauss's law in dielectrics states that the total electric displacement through a closed surface, around a dielectric is equal to the total free charge enclosed in the surface. That is, the Gauss's law in dielectrics states that the total electric displacement through a closed surface around a dielectric is equal to the total free charge enclosed in that surface. This is the Gauss's law in dielectrics. And in free space, we know that in free space there is no dielectric. And hence the polarization vector P is equal to 0. Therefore, D can be written as epsilon E. In the free space, there is no dielectric and hence the polarization vector P is equal to 0, or the displacement, electric displacement or displacement vector D is equal to epsilon 0 E. And if K is the dielectric constant, then the electric displacement can be represented as epsilon 0 Ke. Then considering this equation, that is D is equal to epsilon 0 E plus P, and considering this equation D is equal to epsilon 0 K, we can write this epsilon 0 E plus P is equal to epsilon 0 K into E. Or in this equation, P can be written as P is equal to epsilon 0 into, that is, P can be written as P is equal to epsilon 0 K minus 1 into E. That is, the polarization vector P can be represented in terms of the dielectric constant and the electric field. And here the electric field intensity E and the electric displacement D and the polarization vector P are called three electric vectors. So the Gauss's law in dielectric is del dot D is equal to rho f, or the closed integral D dot D is equal to Q, free charges enclosed. That is, the Gauss's law in dielectric states that the total electric displacement through a closed surface around a dielectric is equal to the total free charge enclosed within the surface. And this is Gauss's law in dielectrics.